Hey guys, welcome to Living the Logic. This is Manish Narayan. We're going to today walk through a simple Python app that's going to help explain blockchain in a very basic way. So the app is going to simulate a blockchain with blocks that contain data, and then it links them together with cryptographic hashes. All right. So we're going to show how to add blocks to the chain and then how the integrity is maintained. And then I'll also show how to tamper with some of the data, which breaks the integrity of the blockchain. All right. So let's get started. What we're going to do is write this in Python. All right. And to write in Python, we're going to create a new file. So I'm going to head over to my environment in Visual Studio Code. Add a new file. We'll call this simple blockchain.py. Okay. Enter. All right. So before we get started, we want to go ahead and import some libraries. All right. So let's go ahead and import a hash library. So import, say, hashlib. Okay. And then we're going to also import time library for timestamps. Okay. So the first thing we want to do is define a class to represent a block, a single block in the blockchain. Okay. So we're going to say define a class to represent a single block in the blockchain. Okay. So what I'm going to do is say class block. Okay. I'm going to define initialization. All right. So we're going to say init self, right? And we're going to add some parameters. So here we're going to add an index of the block. I'll explain each parameter here in a second. So we're going to have a previous hash of the block, timestamp, and the block is defined by the data. And finally, the important part, the hash. Okay. All right. So now let's define the index. Okay. So that we're going to have self.index equals the index incoming. So this is going to be, the index is a position of the block in the chain. Okay. Then we're going to define the previous hash equals the incoming previous hash. And this is a hash of the previous block in the chain. Okay. And then we're going to have the timestamp of the block, okay, which is the incoming timestamp. And this represents the time of block creation. All right. So this is when the block has been created. All right. And then we're going to have the data that's contained within the block. Okay. So this is the data stored in the block itself. Okay. And finally, we're going to have the hash of the block. Right. So this is the cryptographic hash of this block. Okay. That should be hash. Sorry. Okay. Great. All right. So we've defined a block. All right, by its index, previous hash, timestamp, data, and hash. So that's the definition of a block. We can then also define within the class a representation of the block as a string, right? So we can say representation, right? And what we'll do is we'll say return, right? Format, and we'll say block, and this can be defined by self.index, and then colon self.data. Okay, so that's going to be the string representation of the block. All right, now that we have a block, we need to create the blockchain itself, right? That contains one or many blocks. So we're going to have class blockchain, right? And we're going to define the initialization. So we have self, and we'll create a list first to hold the chain. So we'll say self.chain equals a new open close bracket, square bracket, all right? That defines a list. So we'll say this is a list to store the chain of blocks. Okay. And then very important in the blockchain, the very first block is going to be the Genesis block, right? So we'll say self.create. We'll define a method here for Genesis block. Okay. So this is to initialize the Genesis block, the blockchain, with the Genesis block. Okay. All right. So we defined the init method. All right. Now what we're going to do is write the code to create the Genesis block, right? So this following method will create creates the first block in the blockchain, the Genesis block. Okay. All right, so let's define that next. So that's a method here. So we'll say create Genesis block. Okay, and we'll define that, pass in the self here. Right. So what we're going to do is say Genesis block equals a new block. So again, we're using the class we created above for the block, right? And we're going to pass in the parameters. So notice it takes in the set we defined above. So the block is going to take in, let's define it here. So it's going to be 0 for the index, right? Okay. Timestamp was, or sorry, this the first one is going to be, first argument was, yeah, it's going to be the self, the index, previous hash, right? So let's go ahead in the right order. So we'll have 0. Then we're going to have the timestamp, right? So we'll define that as int, and we'll say time, use a time library we imported, time. Okay, and the data that's contained, we'll just call that Genesis block. This is a string, Genesis block. Okay, and finally we need to calculate the hash, right? So self.calculate hash. Okay, define a method here. Okay, so this is going to be defined further down, but we're going to calculate the hash. We're going to pass it the index, the previous hash, and then the data. Okay, so it's going to be 0. Previous hash is just 0, right? Doesn't have one, right? So Genesis block. Okay. All right. So that defines a new block there. Let me just scroll up, make sure we have that correct. Yeah. And then once we define a block, the Genesis block, we're going to append it to the chain, right? So self.chain.append, and we'll say Genesis block. There we go. Okay. So the chain now has its very first block. Okay. All right. So that defines a Genesis block method. Now next we have to define the hash method, the hashing algorithm, right? So what we'll do is go ahead and define the hashing algorithm. So we'll say calculates a hash for a block based on its contents. Okay, so we'll say define calculate hash self index previous hash and the data. Okay, all right. So basically we use a hashlib, right? So we'll say hashlib dot SHA-256. Okay, and we'll pass it a string here, and we'll say let's hash the index together with the previous hash, and then also combined with the data. Okay, and we'll say dot encode, and here we'll use UTF-8, okay, and then once that's done, we'll use a method hex digest. Okay, all right, so this should define our hash calculate hash method. Okay, all right, oops, okay, so now we want to add a new block. So the first block we added was a Genesis block, all right? And then now we want to define a method to add a new block, any new block to the chain. Okay, not the very first one, but the very next set of blocks. All right, so we'll define a method here. We'll say adds a new block to the blockchain. Okay, so we'll define an add block method. Okay, and we'll pass it self and the data. All right. So let's define the add block function, right? So it's previous block equals self dot chain index -1. Okay, so this basically gets the last block in the chain. Okay, all right, that's that position index -1. And then what we do is define the index for the new block. So it's the previous index equals the previous block dot index +1. Okay, so this is an index for the new block. All right, Then we define the timestamp, okay, which is going to be the int of, again, time.time using the time library. All right, this is a current timestamp of the block. Okay, so when this block is created, we grab the current timestamp. Hash value, now this is all simple, right? We have all these methods defined, so we can say hash value equals self.calculate hash, give it the index, the previous block dot hash, and the data. So basically we take the index, the previous block hash, and the data, and again we calculate the hash with that. All right. So this method, or this part of it, is going to calculate the hash of the new block here, right? So calculate the hash. Okay. Then we have the new block equals a new block. Okay. This is our block class. We pass it the index, the previous block dot hash, timestamp, okay, timestamp, data, and the hash value. Okay. And then finally, once we define this new block, we just add it to the, or append it to the chain. So again, self.chain.append, and we'll say this is the new block. Beautiful, right? So this is going to append the new block to the blockchain. Okay. All right, perfect. So we've defined add block, calculate hash, and create the Genesis block. Okay. And then let's define a method to display all the blocks in the blockchain. Okay, so we can print that out. So we'll say displays all the blocks in the blockchain. Okay. So we'll call this display chain, right? We'll define this next. So basically we loop through the blocks. So for each block in the self.chain, right? So each block in the blockchain, okay, we can start printing out the data and all the different properties. So we'll say index, and then here we'll say, index, and we'll say block.index, okay, block.index, and then we'll go ahead and copy this a few more times here. So go ahead and copy that. So 1, 2, 3, 4, 5, 6 times. Okay. All right. So next we'll define the timestamp, and that's going to be block.timestamp. And then we'll define the data in the block. It's going to be the block.data. We'll define the hash of the block. It's the block.hash. And then we'll define the previous hash, so we can at least see the previous hash of the chain. Okay, that's going to be the previous hash. And then what we'll do here is print out dash and then we'll say times 50. Okay. Okay. So what we're going to do next is run a simulation, or define a method which will allow us to tamper with the blocks, kind of destroy the integrity of the block, right? So let's go ahead and define that next. So we'll say simulate tampering, right, by modifying the data of a specific block. Okay. So we'll define a tamper block method. Okay. This is just to simulate and show you what happens when you tamper with a block. Okay. Kind of destroys the integrity, right? Destroys the blockchain, right? So we'll pass it itself. We'll need the index, block index, and the new data that we want to set, meaning what we want to tamper with, right? So what we'll do is we'll say if 0 is less than or equal to the block index is less than the length of the chain. Okay, we want to make sure the block index is valid. All right. So what we'll do here is say self.chain, and then we'll give it the index, right? So it's a block index that we're passing in this method. Okay, and we'll set the data equal to new data. Okay, so here we're modifying, right? Modifying the data here, tampering with the block. Okay, next we need to recalculate the hash, right? So recalculate the hash without updating the chain properly. All right, so this kind of, we're tampering with the with the chain, right? So self.chain, all right, and block index, okay, dot hash, okay, equals self dot calculate hash, and here we're going to pass in self dot chain, and this is going to be the block index, and then dot index. That's required by our method there for the calculate hash. We also need the self chain block index again, and we're going to say dot previous hash. Okay, and then finally the new data. All right. So that defines a tamper method. Okay, that defines a tamper method. All right, and let's create a one final method to validate the integrity. Okay, so we're going to validate the integrity of the blockchain. All right, so we'll call this, we'll put a comment here, say validates the integrity of the blockchain. Okay, so we'll define this as this method as validate chain. Okay, and inside here, basically we're going to loop. So we're going to say for I in range. Okay, 1 and the length of the chain, self.chain. Okay, so here we're going to say current block. This is how this kind of algorithm to validate the chain. So we'll say self chain I. All right. Okay, so we're grabbing the current block, and then we're going to get the previous block. So that's going to be, again, self chain, and then basically we subtract the index by 1. Okay, and here we're going to check if the current block, the hash of the current block, is valid. Okay, how do we do that? So what we do is go ahead and say if, okay, the current block dot hash is not equal to the self dot calculate hash. Okay, so we're going to pass the current block dot index, current block dot previous hash, and finally the current block dot data. Okay, and if this is true, we return false. The chain's broken. Okay, so notice the hash is not equal to the hash of the current block. Okay, all right. So what we're going to do is return false. The chain is broken. Okay. All right. Now we want to check if the previous hash is not equal to the previous hash is not equal to the previous block's hash, right? So basically we wanted to say check if the previous hash matches the previous block's hash. Okay, so we can say if current block dot previous hash is not equal to the previous block dot hash, then basically return false again. Okay, again the chain is broken here. The blockchain is broken. The integrity is broken. All right, if all else is good, we're going to return true. Okay, that means the chain is valid. Okay, so this defines our validation of the chain. All right, perfect. Now, what we'll do is run the simulation. Okay, so let's go and try to create a main entry point to run the simulation. So what we'll do is we'll say if, okay, name, all right, equals, again, main equals, right? So what we're going to do is start kind of a main program, main entry point. So first step in our program, we're going to initialize the blockchain, right? So we'll say initialize a blockchain. Okay, so basically we'll say blockchain equals blockchain class. Okay, we'll add some blocks to the blockchain, right? So we'll add some blocks to the blockchain. Okay, we'll say blockchain dot add block, and we'll call it, again, you could call it whatever you want. We'll say block 1 data. Okay, and then we'll say blockchain dot add block again, and we'll call it block 2 data. And finally, we'll add a third one here, add block, and this is going to be block 3 data. Okay, so we added 3 blocks to the blockchain. All right. Okay, so then we're going to display the original blockchain. So we can say display the original blockchain, And here we'll print out original blockchain. Okay, and a colon there. And we'll basically say blockchain.displayChain. Okay, so we define a method for that. All right, then we'll check the integrity of the blockchain, the current blockchain. Integrity of the blockchain. Okay, so basically we just print out blockchain integrity check. Okay, and here we'll say valid. Okay, so the blockchain is valid if blockchain.validateChain. Okay, else we'll just say broken. Okay, else it's broken. Okay, and now we'll print out tampering with block 2. So let's try to tamper with block 2. Okay, put a new line there and say tampering with block 2. ... Okay, so we're going to simulate here. Simulate tampering by modifying data in block 2. All right, so how do we do that? Well, we defined a method. So we'll say blockchain.tamper block. And remember, we give it the index, so block 2. And we give it some new data here. We'll say tampered data. Okay. So then we'll display the blockchain after the tampering. So we'll say, let's display the blockchain after tampering occurs. So basically what do? We just say, print, okay, and say blockchain after tampering, okay, and here we'll just say blockchain, again, use a display method, so display chain, okay. All right, so once it's tampered with, it display so chain, and then check the integrity after the tampering, right? So we'll copy this, and again we'll say display, check the integrity of blockchain after tampering, let's say. Okay, so again, same thing, we just call validate chain on the blockchain. If it's validated, then it's valid. If it's valid, then it's valid. We print out, otherwise it's broken. Okay, so I'm going to save this. Let's try to give it a run. All right, so we'll head over here in our terminal, say Python, and we'll name the file simple blockchain.py. Okay, method false is not defined, so it looks like I have a bug somewhere, right? So if I bet it's uppercase or lowercase. Let's return false. Okay, let's go back up to our method. Let's check the validate. I'm betting it's a validate. So let's go to validate, and yeah, return false. So it should be a capital F. Same here, capital F. Okay, we'll save it and rerun. Okay, beautiful. So what's happening? Let's see. Original blockchain. This is a Genesis block, right? So we have the hash of the block, the timestamp. Notice the index is 0, and there's no previous hash because this is a Genesis block. We added the second block, okay? So block 1, which is the block 1 data here. Notice it has a hash, and notice it prints out the previous hash, which matches a Genesis block here. Okay. Then index 2 is block 2 data. The hash is defined here, and the previous hash we need to make sure it matches. Again, the block 1 data's hash. Okay, and so on until we get to block 3 data, new hash, and then the previous hash A543 matches block 2 data's hash. Okay, so integrity, when it runs the integrity check, it's valid. Okay, this block, the first blockchain is valid. Now we're going to tamper with block 2. All right, so notice that it prints out the chain after tampering. So notice block 2, we edited the data. Look at that, tampered data, right? Okay, tampered data, and we recalculated the hash. Okay, so it had a new hash in there. So now notice the integrity check says it's broken. Okay, very nice. So again, very high level. This is a simple Python app to demonstrate a blockchain hashing the data that's stored in there. Again, this is just very basic, but I wanted to, at the request of others, I wanted to kind of represent a simple blockchain class and a block class using Python. And feel free to have fun with it. Well, hope you enjoyed the video. I'll see you in the next one. Hey guys, if you found the video helpful, please give it a thumbs up and subscribe for more content. See you next time.